have two speakers tonight for this particular topic, which is on 408 Squadron, the Rockcliffe years. Very honored to have him and his co-speaker. It's Colonel Retired Morris Gates, or Mo Gates, as he likes to be called, and his colleague, Noel, is it Fung? Is that how you pronounce it?
Fung.
Okay, sorry, I just got his bio a few minutes ago, so I didn't get a chance to ask him how to pronounce the last name. So Mo was born in Saskatchewan. On completion of his education in Saskatchewan, he joined the RCAF in 1950, graduating as a navigator from Summerside PEI Air Navigation School in 1951, and posted to serve with 408 Photo Squadron at RCAF Station Rockcliffe, where we currently sit. Next posted in 1954 to Winnipeg, where he took the advanced navigation course prior to performing instructional duties, and following which he attended a one-year special navigation course. From 1959 onward, he served in Canada and abroad in various air navigation training assignments, including with the Central Experimental and Proving Establishment on the newly produced Argus aircraft, and also conducting the Doppler radar water motion trials. Completing Staff College in 1962, Mo rose through the officer ranks and served in increasing levels of responsibility as Staff Officer in Navigation Training, Commanding Officer 404 Maritime Patrol Squadron in Greenwood, Nova Scotia. I believe we have some of Mo's colleagues, former colleagues from Greenwood here tonight. Welcome. Deputy Commandant of Maritime Warfare School in Halifax, Nova Scotia, Base Commander CFB Winnipeg, Secretary of Staff Allied Forces Europe, Director of Policy and Administration for non-commissioned ranks. Mo, I don't think you ever got bored. All these different assignments. Finally, as Chief of Personnel and Administration at the Canadian Forces Training System, Trenton, Ontario, from where he retired in 1985. Since retirement, he's been busy supporting the Greenwood Aviation Museum, the RCAF Memorial Museum, and has co-authored several books. Nadar to Zenith, which I'm sure many of us have read, an almanac of stories by Canadian military navigators, Polar Air Navigation, a record, and 408 Squadron, the Rockcliffe years. So now on to Noel. He was born in Melbourne, Australia, and entered the RCAF in 1953, graduating in 1955 as a long-range navigator. Spent 32 years service in the Air Force, amassing 9,500 flying hours in transport and reconnaissance duties, as well as spending 8 years as an instructor on the Aerospace Systems Squadron, 4 as the commander. And that's now known as the Canadian Forces School of Aerospace Studies. We actually have at least one of our members is a graduate of that school. Of his flying hours, 3,500 were flown on C-130 transport duties, 2,000 on the Dakota, 1,000 of which were on skis, 1,000 on the Photo Lancaster aircraft. 3 of them were modified for navigational training in the Arctic, as well as Arctic photography, Polaris, Zenith, and Northern Cross. My dad flew all 3 of those aircraft. Noel also has 900 hours on the Canberra aircraft of the Royal Air Force, and 500 hours spent on VIP Comet duties at 412 Squadron. Noel retired as a major from 14 Training Group in CFB Winnipeg in October '85, and as with Mo, they now live in Trenton, Ontario.
Well, good evening. Mr. Chairman, Sponsor Don McNeil, and ladies and gentlemen of the Aviation Historical Society. We're pleased to be with you this evening to tell some of the stories about 408. During its stay here in Rockcliffe from 1949 till 1964. During that time, it conducted operations in 2 main areas. First, in completing the photography and the survey of the country that permitted the first accurate map of the country to be produced. And second, it performed extensive Arctic surveillance during the Cold War that contributed to national security and indeed perhaps even world security. In late 2012, our group of X408 members, then 9 in number, but now just 5, unanimously agreed that a better story of the Rockcliffe years was needed if the nationally important achievements of 408 Squadron were being recorded semi-historically and also be in a form suitable to public consumption. Work then began to put the story into a book that, published in 2014, occupies 585 pages. One part of which tells the group's effort to place a monument in the grounds of the RCAF Memorial Museum in Trenton, honoring all those who served with 408, including the 936 men who lost their lives during the war in Bomber Command. I have to say at this time that we're going to focus on the why of the task was assigned and what was accomplished. The how has to be much abbreviated. There is no way we can tell this story in an hour. So we've only included in the how bit what's necessary to make the story clear for you. The why of the photo survey task is readily explained. The government at the end of the Second World War established a goal that the country would be mapped at a scale of 1 in 250,000, or 4 miles to the inch, by 1967, Canada's centennial year. At that time, only 3 of the required 913 map sheets were available. And, of course, they had to be done by that date to meet the government's required. Our story of what was accomplished will be related in 3 parts. First, the part regarding aerophotography of the country. Second, the charade story that placed the photo features in the correct place on the Earth's graticule. And third, the reconnaissance carried out during the Cold War period. In the conclusion, I will mention several other tasks that were assigned to the squadron, but we have minimized them for the sake of time. My earlier comment about the lack of recognition needs some further explanation, I believe. Firstly, the taking of photographs of the countryside could not compete for recognition alongside the early events of the Cold War. It just was not as newsworthy. And secondly, many of the other squadron tasks, but particularly the Arctic reconnaissance task, were so highly classified that the public was denied any knowledge of them at all. And again, thirdly, the squadron activity was mainly in the sparsely settled north, where the media was to be found in very small numbers, if at all. A brief squadron history was written in 1984, but the Rockcliffe years and the mapping and survey tasks received only cursory treatment in a small book that was telling the story from 1941 until 1984. At that time, the squadron had been a helicopter squadron for 14 years. Now, let's go on to the Rockcliffe years, beginning with the photo operations, and this story is going to be recounted to you by Major Retired Noel Funch. It'll be followed by me with the Cheran story and the reconnaissance story. But I do want to advise you that at this time, there are several other members of the squadron who were in Rockcliffe during these years, and they're with us tonight, and they may be able to help answer any questions that may occur later. And now, over to Noel and the photographic.
What Mo said a few minutes ago was really directed towards 408 Squadron, but the book that we wrote really encompasses the whole of aerial photography in Canada from the very start. I want you to know that the story of 408, if it was told by itself, would not be very complete, because it would start when most of the mapping of Canada was almost complete. the photography had been largely done by others, and I will cover that tonight as a preface to what Bo is going to tell you about the main part of the story, which was the actual control of the photography, the most important part in many respects, because photography without control is pretty useless. That is to say, the actual points on the ground that you can tie the photo into that make it usable from a survey point of view. That is to say that the photograph is tied precisely to the ground points. Mo established the need for an actual national survey, but it was all brought about after consideration in Paris in 1913, where all nations were mandated to have their nations, their countries mapped at a scale of 1 to a million. That is to say, a scale of 60 miles to the inch. Canada, after the First World War, had a lot of people that come back from using aerial cameras to photograph tactical advantages in the trenches, from balloons and aircraft like the DH-4s. And I guess if I press this thing in the right spot, I should have that one. And then the DH-4 was an aircraft of the DH-9, which is similar, was typical of the aircraft used in World War I, with a photographer hanging over the side, or sometimes they strapped it to the aircraft or built a hole in the floor and took pictures of trenches. Other people took it from balloons. The first actual photograph taken in Canada, I guess, was taken from Halifax, of the Halifax Citadel from a balloon, but that's just historical photography fact and little use to us. There were 1,300 combat flyers that came back from the war, World War I, such as Basil Hobbs, who was good at shooting down Zeppelins, and I'll mention his name later. Some names like McEwen, Holland, Brebner, Croyle, McBurney, well-known names in Canadian aviation history and the RCAF, were the nucleus of the embryonic Royal Canadian Air Force, and began work in photographing Canada in the old wooden wire machines. After Confederation, 4 million square miles of Canada. Who would have thought that Mr. MacDonald knew what he was about? All you could see was from the top of a hill. And the surveyed part of Canada then was probably about the same you get from your cell phone coverage. It wasn't very much surveyed at all. Yes, we had maps, and there's one here, I think, that shows it all. Here's a map I got from the archives of Canada in 1920. Well, you can see all the land is there, but in the middle of Canada, there's Great Bear Lake and Great Slave Lake, and there's a lot of nothing where lakes and rivers should be. The explorers have been there and they've done a lot of work. Coastal areas are done by navigators, particularly after the Franklin expedition. A lot of the Arctic islands have been put into place. But not much was done in the way of survey, and so we have to deal with somebody who was going to take aircraft from World War I. At the beginning of 1920, they formed the Canadian Air Force with the RFC guys that had come back, and they started using aircraft from the Imperial Gift. That was like the DH-4 that I just showed you. And there were about 100 aircraft given by the British to Canada, and some from the US Navy that I'll mention in a few minutes. First of all, we've got to establish a couple of relationships. Everybody knows about cameras, I'm sure. You've all used one, film or digital. But to go into talk about aerial photography, a couple of issues. Scale. If we look at the camera relationships, you know that there's a lens, and the center of the optical axis of the lens is not necessarily at the lens itself, but in between the elements of the lens. And from that crossover of light rays in the lens, from there to the film at the back of the camera, to the object, which is usually, in the case of aerial photography, the ground, and that ratio from the image on the ground to the film at the back, the ratio of that on that optical axis of the two values is known as the scale. If you're 20,000 feet and the focal length of the camera, as to say that between the lens and the film, is 6 inches, the altitude is 10,000 feet, we say 1 in 20,000. Now further, we have some relationships in aerial photography that you've heard the terms, and I'll explain them just quickly. Vertical photography, usually done, we think of aircraft flying over the top, have a camera looking downwards. You see, from the camera to the ground, the lens of the camera to the ground is known as absolute altitude. And the focal length of the camera compared to the altitude is the scale. So if you're at 40,000 feet, the camera is 6 inches, it's 1 at 80,000 is the scale. You have on the right-hand side, high oblique is the camera pointing out of the side of the aircraft, can be fixed to the camera or pointed out the door. High oblique, you see the horizon. A low oblique, you don't. So those are the relationships that are important in photography. Now in 413 Squadron, in the early days of photography after the war, we had B-25 aircraft fitted with a type of camera array called a trimetragon. And that was 3 cameras tied together in an array called trimetragon. Now I'll have to let you use a bit of imagination here, but if you see the central square in the middle, that was the vertical photography, the line up the middle of that photograph that you see there, from at the bottom of the image to the top is the line of transit of the aircraft. The square in the middle is the direct nadir of the aircraft. That is to say, the position of the photograph directly below the aircraft. The two distorted images to the right and to the left are the oblique images of 2 cameras that are set at 60 degrees to the vertical in the array that was carried in the nose of the Mitchell aircraft. That particular array, which is called trimetragon, you can see the little image of a small aircraft there just above the center of that image, is photographing that strip, and as it proceeds along that line, it films, it takes a picture of everything from horizon to horizon. When we first started off in the photography of Canada, people who were doing the photography, those squadrons who started it off in the very beginning, photograph lines, and a rough image was taken. The lines parallel flying north and south were taken, and the mappers could take images, and there was no gap. If you fly vertical lines and you can't get them close enough together, or if there's no overlap, there are gaps which frustrate mappers and people who try to put the images onto paper. I'll use these terms, gap and no gap, as we go into the further applications here. When you're doing a coverage of an area, you in vertical photography, and you run a line of images like that, and you do a series of them, you do what is called a mosaic. And here I've shown an aircraft going along with a line of vertical photography. In the bottom part of the image, you see 2 lines side by side. The first 1 through 6 are one line, and 7 through 12 going the other way are overlapping lines which, together with the first 6, overlap by 20 to 40%, so that the people who are the photographic section who are printing the negatives of the photographs that are taken can overlay them and get complete coverage. It's important to have overlap. Between 1, 2, 3, 4, and 5, and 6 is 60% overlap. The reason for the 60% overlap is then that the photo interpreter, the person who's looking for cultural features on the ground, can use what is called a stereoscope. And I think most people know when I talk about a stereoscopic vision. You can use a little optical device to look at things in three dimensions, and he can pick out things which are culturally different from others and stick out from the ground. Enough of that. I've got to cover this in just a few minutes. Here's one of the other aircraft, the HS-2L. It was given to us in the Imperial gift. And this from the U.S. Navy. Pardon me, not the Imperial gift, but given to us by the U.S. Navy. And it proved to be a very hardy beast indeed. You can see it has an open cockpit in the front, and that was where the photographer sat and dangled out with his camera. Pilot sat right behind him, and usually they had no navigators until World War II in Canada, so the navigator usually turned out to be a Department of Lands and Surveys, some gentleman who came from the Department of the Interior and showed the pilot how to get around, because there was no other way. There was nobody who had ever gone the air before and steered around, but a surveyor was a good guy to have on the aircraft because he knew more than anybody else. So, in the end, we got another aircraft from the Imperial gift. Was a Bristol fighter, well known at the end, 1918, 1917, 18. It was a very hardy brute of an aircraft. I think it's a bit distorted there. It looks a bit fatter than it needed to be. When I was putting this into the PowerPoint display, I think I got the vertical a little bit skewed. But it has a gunner with a scarf ring in the back, and it seemed to be a perfect place to put a camera. So they did. In 1920, then Captain McEwen, Black Mike McEwen, who later ended up being the commander of No. 6 Group in Yorkshire during World War II, using this Williamson L2B camera, which is one of the earliest cameras that was used by the Canadian Air Force and the RCAF in 1920, did a mosaic of Ottawa. Now look at that. That's pretty good for 1920. You can see on the original one that I got this from, you can see in that black spot just east of the Parliament buildings where the photographs actually overlap. You can see it if you look closely in the original that I had, but unfortunately it's not evident on this one. There's Black Mike McEwen as a squadron leader in the Royal Canadian Air Force sometime after that job was done. But he complained that he tried the Avro 504. It was too hard to handle, it was too stable, but the Bristol fighter was just a little bit too frisky. So it was a little bit hard to manage for photo, but he did a good job. And then one of his confreres was Captain Holland, another guy who did great work in photography in the 1920s. Okay, one of the best cameras they had that period was called the Fairchild K3, and it had the unique ability to have a between the lens shutter. So it cut off the rays going back to the film instantly. Most of the cameras before that had focal plane shutters, which had a slit in a blind that went across the film, and it distorted most of the photography that was taken, unless it was really quick. And of course, as a mechanical device, it wasn't quick enough, so there's distortion evident. This focal plane, between the lens shutter, which proved to be the forerunner of much better ones in the future, and the focal plane shutter has its merits too, but this one was better for aerial photography, and this was one of the pioneers in 1920, the Fairchild K3. Fairchild made a lot of cameras, as you'll see later. One of the problems about vertical photography in the 1920s was that the aircraft couldn't stagger up the heights quick enough. An HS-2L or Vickers Viking, when they got them later on, it took about an hour to get to 3,000 or 4,000 feet. So they wasted a lot of gas trying to get up to take the photo. So they said, why not try to make something out of oblique photography? So with Canadian inventiveness, we're renowned for compromise and inventiveness. Well, I'll show you this first of all. This is a camera operator, as I said before, in the front of an HS-2L. There's the great Rolls-Royce Eagle engine, and the mechanic who went along. There were three in the crew: the pilot, the camera operator, and mechanic. and the mechanic used to have his pocket full of rockers. You know, the rockers for the engine, because they wore out all the time. And the mechanic used to have to, the aircraft was light enough that if you got into the river and have to patch it up, you could lift the aircraft up, but the 1920 equivalent of duct tape over it to patch it up. But anyway, that's how flimsy those aircraft were. And there's the camera, as you see, on a kind of mounting. This is what they did with oblique photography. The Canadians came up with a method of putting a graticule over it that could reconvert back into something that the plotters could use to convert it back into a plottable map that they could put onto a planar surface, from oblique distorted photography back to rectified photography. That was known throughout the world as the Canadian method, because all countries were anxious to find out a way to utilize oblique photography. So we pioneered that in the 1920s, I'm proud to say. So this is the Vickers Viking that was introduced into service about 1925. And it was a pretty good aircraft from the RCAF point of view. It worked in long, hard service for many, many years. This is what the guys used to stay in, because they moved from all of continental Canada, right from the American border in detachments, right up to as far as Coppermine, all the way from the Alaskan border across to the East Coast. They camped out, bush pilots in uniform, is what I like to call them, because they were not well treated by the government. They had very little money, and they certainly didn't die in palatial residences where they were. But where they had to go, you know, with outfits like this, there's a Vickers Viking, and there are the crew. Squadron Leader Basil Hobbs, who was so intent on shooting down Zeppelins in 1924, he did about, at 5,000 feet, took 1,700 photographs of the Churchill and Reindeer Rivers up in northwest Manitoba area, and 4,000 square miles have been covered, and 40,000 square miles were received at the end of his travels by the topographical bands down in Ottawa. So they did a good job, and one of the photographic section that worked there was a fellow called Flight Lieutenant J.R. Cairns. J.R. Cairns, who in the annals of Canadian photography turned out to be one of the most brilliant guys we have ever known in that area. J.R. Cairns. 1925 also saw the immense survey of the Hudson Bay Railroad, and originally it was going to go up to Fort Nelson. But the pilot who flew up there to do this photo survey from his airplane, the advantages of being up there, he saw that the port was too shallow and it wouldn't do to have a port there. So he came back and he said to Mr. Wallace, who was the general surveyor, he said, "This won't do." He said, "We've got to find something else." So they recommended Churchill. And as you know, they spent a lot of time putting in Churchill, and it proved to be the outstanding port that it still is today when they get the railroad fixed. Okay. The 1920s turned out to be the lean years. When the Depression took place, they had probably in 1929-30 a budget of aircraft appropriations was $6 million. Doesn't sound like a lot today, but they allowed them to buy 7 Vickers Vedettes, 3 Vickers Vancouvers, and with a budget increase to $7.5 million in 1930-32, the RCF attained the large funding that it was to receive after the Great War until the years before World War II. In 1932, was reduced to $5.2 million. The next reduction was to $1.7 million. In between there, the 5.3 and the 1.7, they were lucky to get the Belenka pacemaker, okay, which turned out to be a really hardy float plane vehicle for later photography. It was a super aircraft for fan cameras. Now remember I talked to you about the Trimetragon, which is three cameras deployed to see horizon to horizon, where the Blanca pacemaker and one other aircraft I'll show you in a minute were purveyors of that kind of photography. In the back fuselage of the pacemaker, they were able to put those kind of cameras in. And later, the Northrop Delta. Okay? Turned out to be a look towards the future of modern development in 1935. So after the lean years of 1932, 1934 went up to 2.3 million, 1936 to 6.8 million. Then they bought the Northrop Delta. In the pre-war years, they got the fan cameras going, and got the Fairchild 71 later in 1927 as well. But this is an idea of what it looked like in the back of a Fairchild 71. And it was similar in the Blanca pacemaker. This is the kind of setup they had through the semicircular fuselage in the back. They put the horizon to horizon with the aircraft, with the two cameras looking out each side and a vertical in the middle. To give you an idea, when you're flying those lines with, okay, so just back up a bit. All of the film was processed in Ottawa at a place called the White House. It was on the eastern end of where we're standing today, just at the eastern end of where the hangar line was. It was built in 1936. And the central floor was occupied by the RCAF Photographic Branch, and the second floor is occupied by the Army Survey Establishment. In 1944, when just jumping ahead to during the war, it was staffed by upwards of 100 technicians. But they did, during the active 10 years of air survey, they printed 10 million aerial photographs, just to put you in the right frame of mind about how busy these guys were. This particular room where these guys were working was called 2PS, number 2 Photographic Establishment. Okay, so that's what it was like prior to the war. Okay, so in 1944, the number 7 photo wing was formed to carry out photo research. At the end of operations in 1939, all of the photography that had been done prior to the war was 868,000 square miles, roughly about a fifth of the coverage of the nation. 868,000 square miles was done prior to the war. So in 1944, they started photographic operations again. Okay, with a Mitchell, a B-25 Mitchell, with that Trimetragon fan that I was talking about. You can see the nose of the aircraft. You can see the one port on the right-hand side, which is very evident. You can see the one under the hands-off sign, the vertical camera, and of course there is one you can't see on the starboard side, on the right under where the man is standing, which completes the Trimetragon array. They had a crew of a camera operator in that nose, they had a navigator in that nose, they had 2 pilots behind them. It was very tight squeeze in there with the cameras, let me tell you. I did about 80 hours in a Mitchell without that array, and it's very tight, just with 3 or 4 guys up there. I don't know how they did it for 12 hours at a time at 20,000 feet, let me tell you. But there is the 413 Mitchell that they did with the 3 K-17 Fairchild cameras. So, one of the guys who led all of this photography training in 1944, and one of the aircraft they did the vertical with at the same time was called an Anson Mark V. Now, you all heard, probably those of you who are old enough, that an Anson, it went up. I flew in one in 1964 in the RF Anson Mark 21. So, but it had undercarriage that were retracted hydraulically. Before that, you used to have to do it with a crane handle. But here's one, 1944, not too far away from where we're standing in Rockcliffe. It was used for vertical photography at 20,000 feet. Can you figure that out? But anyway, they used them to do the first of the vertical photography in Rockcliffe. Okay, but results obtained in 1944 by number 13 Squadron, which had been formed with a number 14 Squadron under 7 photographic wing. They did at 20,000 feet, 85,000 square miles of an ambitious 300,000 square miles because of heavy smoke from forest fires. But 14 Squadron in the vertical side did 186,000 square miles of vertical out of 200,000 square miles. So that boosted the morale of the vertical people. In 1946, number 13 Squadron did Winnipeg and the Paw, and they had a thing that Mo will describe to you, I'm sure, better than I can. But it's a device that was absolutely crucial to trimetric-on navigation, because to fly north for 12 hours, or lines for 12 hours, not necessarily one line for 12 hours, to fly lines that went north and south for 12 hours, and you had an instrument called a B3 drift meter, and most of the aircraft that flew after 1945 it was an American device with gyro stabilized, and it could be used by looking forward as a kind of bomb sight, primarily used for taking drift. It was gyro stabilized, so you didn't have to worry about turbulence. But this device, plus the solar navigator, the solar navigator could be, it was a mechanical device that could be adjusted for the advance of the sun as the sun traveled across the sky, and since you flew up the meridian, when you're flying north and south, you didn't have to worry about the convergency of the meridians, and you could allow for the passage of the sun as you went further, higher in latitude. You could allow for the latitude and the passage of the sun, so you could keep the perfect heading, and with the drift you could maintain a perfect photo line. So aircraft in those days that were flying the Mitchell aircraft and the Anson, later the Dakota aircraft, were using the solar navigator. So 14 Squadrons kept on with this. I won't worry too much about the amounts. The Williamson OSC camera eventually superseded in vertical photography the K-17 and the British Eagle 9 that they were using for vertical. And the Williamson OSC was designed to be almost the perfect vertical camera for Canadian use, and was used right up until the time I was doing photo in 1950s. In 1947, 414 Squadron operated from, every year they operated 4 photographic detachments from Rockcliffe, and they went from the Paw, Norman Wallace, Fort Simpson, Edmonton, Watson Lake, Yellowknife, and Port Radium. They were tasked with 100,000 miles of photography, and they achieved 111,000. So in conditions that were primitive, I gotta say. In 1948, 413 Squadron was at Coral Harbor, Frobisher Bay, and Fort Chimo. They carried on with the TriMet. 414, Watson Lake, Fort St. John, Port Nelson. Between the two of them, these two squadrons did 911,000 square miles in 1948. So, thus, at the end of 1948, 55% of the nation was on film. So for 868, as I said before, 868,000 square miles, 1939. Now we've got 55% of the nation on in 1948, and it's getting better. 1949, the government decides to get really serious about this business, and 408 Squadron is reformed. This is where Mo comes in for his Sharan. Previous to 1949, 413 Squadron with the Mitchells and Lancasters has been doing some preliminary work on the shore end. That's not my area. I didn't do any shore end. Mo did. He'll explain it to you. I'm a photo guy, but the aircraft were all primed up to go, and Wing Commander Chuck Olson, I meant to mention a minute ago that one of the prime guys who taught us everything about photo in the RCAF after the war, 1944, 45 and onwards, was Maury Connick. He rose to be a squadron leader. He was a wartime navigator. He was a sergeant in the 1944 days. He was my mentor in the photographic area. I used to sit in the bay window in the mess in Rockcliffe and talk to him endlessly about photo. He was the guy. And later on, when I went over to teach the 104s to do tactical reconnaissance with the photo pod, he was the guy. So, one guy, he was a member of our team that put the book together, no longer with us, always to be remembered as a great photo guy in the RCF history. Thank you, Maury. I got to tell you that 1939, there's a picture of Fox Basin. The photography we took in 1948 found 2 islands in that basin. One of them was Prince Charles Island, and one was Air Force Island. And when a couple of years earlier, one of the aircraft had relocated the Spicer Islands and checked that they were there, and there had been some concern about where the Spicer Islands were, but one of the navigators and crews found that the Spicer Islands were exactly where they're supposed to be. You can see them up there just under the term Fox Basin in the upper right-hand quadrant. But they never saw the other islands. Why? Because they were covered with ice, and they were too low to be in any way distinctive. 1948, one of our crews went over there and found the 2 islands, and it went on record, Prince Charles Island and Air Force Island. Wing Commander Chuck Olson was the first commander of 408 Squadron, 1949, January. And so we started off on a new period of photography to wind it up, get it done. As I said, 1948, 55% had been done. Now it was full bore. Aircraft came to Rockcliffe. 10 Lancasters, I believe, we had at the beginning. No? 10.
Sorry?
10 photo Lancasters.
No, we only had 8. And
Eight photo Lancasters. They got there before I got there in 55. But anyway, they started off with a full complement of the Lancasters, but 413 Squadron, which had stopped using the Mitchells the year before, was doing transport support for us with Dakotas and Kansos and Norsemen and Otters. 408 Squadron started flying the photo line, vertical and trimetric, and winding it up. At the same time, they started off the Sharan program that Mo will go into in a few minutes. So we started off with the photo Lancaster, and it will also do the Sharan work. You look at the photo Lancaster that we were equipped with in 1949. This is MN122. You'll see under the RCF roundel the camera port for the trimetric survey, the starboard facing camera port, and there's a corresponding one beneath the aircraft for the vertical. Just ahead, under the middle 2 of the 122 and just behind beneath the back of the inboard starboard engine nacelle, you can see quite a pronounced protrusion there. That is a vertical camera flat, okay, for the Williamson OSC. The camera operator had that whole area to himself and a great array of cameras and bracing. Underneath the aircraft, you can see two little small T, very small Ts. They were radio altimeter antennas for bouncing waves off the ground, and they were used for something I'll describe in a minute called airborne profile recording. Now, that was used for altimetry of ground heights and the terrain, differences in terrain elevation. The aircraft at that time were equipped with a variety of cameras. We had the precision camera and that protrusion I showed you forward of the trimetric gun, the three f2.24 6-inch focal length cameras for the trimetric gun. We had a variety of f52 aerial cameras that were made by Fairchild with 6, 12, 20, 24, and 36-inch focal lengths. Could be used from the side windows or the vertical, as the camera operator chose. And they could be used from existing ports or handheld out the door for air-to-air photography. We had a device called a Sony S7A continuous strip camera with image motion compensation. It was invented by an American in 1946. And this device, we used to fly over targets about 100 feet, and the film moved back past an open slot in the bottom, in the frame of the camera, and the film moves past at the apparent speed of the ground moving past it. So you get continuous strip, high precision, high resolution images on the ground. So very useful flying over targets that Mo will describe to you in our tactical reconnaissance missions that were highly classified later. But it was useful for things like 1957, Air Commodore Ripley from Air Material Command crashed at Bishop Mills, and I was sent on a mission down there to find out where the wing came off of the Mitchell he was flying in, and we found the parts of the wing by flying over the Sony camera at 100 feet. We were able to isolate every part of the aircraft that had detached from the airframe using that camera. Very useful piece of gear. As well as the Sony S7A, we had a 20-inch focal length camera in the front of the aircraft. Four 1,250 horsepower Packard-built Rolls-Royce engines, which took my hearing away, and we had a solar navigator in the front. You'll see in the very front of the aircraft a little dimple right above one of the round ports in the nose there. Little wee dimple. Not the antenna just in front of the pilot's face, but little dimple. That's the solar navigator, which was track the sun. And crew of 2 pilots, 2 navs, a radio officer, a flight engineer, a camera operator, and sometimes a crewman on detached operation. Airborne profile recording was, as I said, a simple device where we used to fly over terrain that we wanted to measure for the mapping people in Ottawa, the Department of Mines and Technical Surveys. We'd find parallel lines over islands and other terrain from known heights to known heights. That is to say, on an island, we'd fly from sea level across the island to sea level. Or inland, you'd fly from maybe Lake Superior to Lake of the Woods or something like that, where you knew the height of one level and flew across terrain to a known height on the other, so it could define precisely the height of the terrain in between. Do that for a series of parallel lines, and it was useful to them in appointing contour levels to around the photography. So in 1949, footed detachments are at the PA, Yellowknife, Coral Harbor, and Churchill. Number 8 detachment at Winnipeg. The opening season, 493,000 trimet, an awful lot of photography, almost 500,000 square miles, and 60,000 square miles of vertical. 413 Squadron Dakota supported detachments. And unfortunately, one of the aircraft crashed, and Wing Commander Olson recommended that those decks be part of 408 Squadron, which actually happened quickly thereafter. In 1950, 408 Squadron was plan to continue with TriMet and Vortical as shown on the map. 3 detachments were formed and moved to Yellowknife. And Resolute went up to Resolute on the 13th of June, but trouble with Resolute, Resolute Bay in Cornwallis Island is, everybody wants to go there in the summertime. Everything's crowded, hard to get food. When you want to go, as Mo said before, in an aircraft where there's nothing on board the aircraft to cook anything, so if you don't get meals, you starve. It's an awful situation where morale falls down pretty quickly with the air crew if you can't get meals at the base, and you can't get too much to heat up in the aircraft. So in 1950, 408 Squadron detachments achieved 405,800 square miles of TriMet, and on top of the 500,000 they got the year before and 78,000 square miles of vertical. So they were really wrapping it up very quickly. So the photography is almost coming to an end, and Mo's business is starting to get into high gear. At the same time, 414 is wrapping up its vertical photography, and in 1950, I guess it is, they did 200,000 square miles, and at the end of the operational year of 1950, 2,400,000 square miles of vertical and 2,200,300 square miles of tri-camera had been obtained by the RCAF. There remained only 10% of the country to be photographed. So in 1951, and actually 1950 I think was the last year of 414's operation, and they became after that, I think they became a CF-100 squadron. So they were disbanded as a photo squadron. 1951, operation started off at Yellowknife, finished at Fort Nelson, went to Yellowknife, started operations from Churchill. They did a small amount of trimetragon. On 1951, Wing Commander Smith assumed command of the squadron. Jackson was next. This is the coverage in 1950, and you can see, except for a gap on Melville Peninsula, and just next to, just right next to it there, a small part on that peninsula there, and up in the north, the right-hand side of Devon Island, and the bottom half of Ellesmere Island were the only remaining parts to be photographed after 1950. That was looked after in 1951. Here's a Yellowknife detachment operation, what it looked like in 1951. 1951, Coral Harbor termed itself the 7th Northern Air Force. Thought you'd like to see this. Good example of how morale is lifted up by guys who get together and form a team. Wing Commander Smith took over 408 after Wing Commander Jackson. And get back to my page here. It was all wrapped up in 1952 pretty much, except for some gap flying. 1954, some more gap flying. 1954, this gentleman who went on to make quite a name for himself, Wing Commander Schaller, took over the squadron. He was my leader when I came in 1955, and I'm sure Mo will talk about him. In 1955, there are only 200 linear miles left of photography to be finished for the whole of the country, and it was done quickly thereafter. For the remaining years of 1956 to 1994, most of the photograph was tasking for military sites and other jobs. No lack of interest, no lack of activity, but the photography of Canada was finished, and the photo squadron went on to other tasks in reconnaissance and other activities that Mo will describe to you in some detail. I'm sorry that it's been a bit chopped up, but to cut it all down to half an hour or whatever taken is quite a feat, and I'm glad that not all of you have gone to sleep. So thank you very much for your attention.
Noel talked about the poor situation that prevailed in 1949 respecting the photo coverage of the country, and I can only add to that condition because Canadian maps were in, that we were showing the survey condition that was necessary, just didn't even exist. Here's the triangulation state that existed in 1949 when Photo 8 took over. That heavy black line is what was surveyed by what was known then as first order triangulation, that is to 1 part in 100,000. The rest of the country, no. It wasn't there. We never had the triangulation to support the maps and the photos that had been taken that Noel spoke about. Yes, there were lots of photos taken. We didn't know where to put them. And I'm sorry the pointer on the machine doesn't work, but if you look up by the hook on the left-hand side of there were map sheets up in that area that in 1955 I could take out of my map project bag, and sheets were blank. Absolutely blank pages of paper. A lot of it, the information that was along the North Shore, Queen Maud Gulf and so on, south of Cambridge Bay, that was information that came from Sir John Franklin's land survey in 1825. That's the state that the triangulation was in. Of course, in that area, the triangulation was by measuring angles and starting from a couple of known positions, and then you could extend the baseline out and find another position by that method. Or the other system was by using a traverse, where they used the theodolite and a survey chain, and they measured distances. You can imagine how slow these systems were, and they were. And neither one of them were suitable for the rough terrain that constitutes most of Canada. It just couldn't be done. And yet we were asking for a map completion date of 1967. The alternative survey in the hinterland areas that was used was astronomical observation points. But these positions lacked a relationship one to the other. You might know the latitude and longitude of point A and of point B, but unless you use those to calculate something, there was no way of relating them directly from one to the other except by mathematics. On the other hand, the accuracy of the astronomical points was only between 200 and 4,000 feet. And the reason for this was that the instruments that the observation crews were making were dependent on the local vertical. And the local vertical was deflected by the varying density in the Earth's crust. And there was nothing they could do about it. Added to that error, there was another one, and I think this one is just as readily understood, that when you're trying to take astro sights on stars during the day, you have a problem. And that's what was happening for the most time. The work was done in the summer months, the high latitudes, daylight all the time, and you're trying to observe a star. You can with a very long telescope on something, but the accuracy is going to suffer, and it did. So the astronomical survey system wasn't up to meeting what the government required of an accuracy, and that was 25 meters. Each point was to be established within an accuracy of 25 meters. Now, let's turn to SHORAN. SHORAN is just an acronym for short-range navigation, and the SHORAN set was a blind bombing system used by the U.S. Army Air Force during the Second World War, mainly in Italy. It did work. The system was developed by Radio Corporation of America, and the system never got widely used during the war, and it first came to the recognition of people in Canada in 1946. And it was done by two separate government agencies that were looking at it. The first one was the photo establishment, and here's the OC of the photo establishment, Wing Commander Don Ross, and he was looking for a navigation system that could be fitted to the aircraft that would prevent gaps in the photo coverage, because they were very costly in flying time, and they delayed the maps dreadfully from 1 year to the next, at a minimum, before they would be redone again. The other government agency that was looking at it at the same time was the Ministry of Energy, Mines and Resources, and specifically the Geodetic Survey Division. And they were looking for something that was going to meet this requirement of 25 meters accuracy over the whole country by 1967. And Mr. Ross, there was no relationship to these two Rosses, he picked up on this RAM as well, and I got interested in it, and he won the toss. They decided that it was going to be the survey system and not used for the photo lines. They formed a team, and there were slides not there. They formed a team, NRC, Army Survey Establishment, Geodetic Survey, RCAF, and they started the investigation as to whether Choran could actually ever meet this requirement of 25 meters over a long arc, because that was the problem of trying to do Canada, to extend it over a long distance. Well, anyway, by 1947, all of their investigations had been complete, and Choran was selected as the survey tool. And the team now set out about testing the system. And again, I must refer here to one of the critical things was this idea of looking about extending it over a long arc. And when I'm talking about a long arc, I'm talking about a survey going from Ottawa to Edmonton. That's the sort of thing they were looking at. Could you continue these little measurements over that sort of length and still have the accuracy of 25 meters at the other end? Now, the testing took place over the winters of 47, 48, and into the spring of 49, and at which point all of these aircraft and people that had been doing this on 413 were transferred to 408. The RCAF trials coordinator was a Flying Officer Art Nordman, a very bright man, and he stayed with the system for a long time, and after it was put into use, he was the Choran Operations Officer in 1949. Now, one of the tests that had to be determined when they were doing these flying tests was how many crossings of the line would you have to make to have an accurate reading? And the number they came up with was 16. And this was done in 2 figures of 8, with 8 crossings, or transits as we eventually called them, being flown on 2 consecutive days. You couldn't fly the whole 16 transits on the one day. Atmospherics played games with us, and so you had to do it on 2 different days. Now, the crossings of the lines, here you can see the idea of the crossings, and the figure 8 is down there in the right, but the plan that's immediately above it, of the internal crossing, they were all done at an angle. And the reason they were done at an angle is if you're using a radar set, as we were, and I'll show you this in a moment, the operators were twiddling knobs to keep the pulses lined up. If you're doing this, and you've got a gear train doing it, as you approach the minimum distance, there's all kinds of slack in the gear train. Doesn't matter how good that gear train is. So both of the numbers are decreasing. But if you cross at an angle, one side is increasing, the other one is decreasing, and it does it for the whole time, and you get rid of this slack in the gear train. And so that improved the accuracy enormously. So that was the idea of the line crossing. In the lower left, there's talking about an external line crossing. That was designed for a specific use. It was never used. Here's a Schran set, and you can see the scope up there. It was a J scope. And down in the lower right, you can, at the lower side, you can see the two handles of cranking that the operators use to line up the pulsers. And there's what they had to do. There was one coming from one side of the aircraft and one from the other side, and they had to line it up with the marker pip. Now, another part of the trials was resulted in improving the part played by the navigator in the line crossings. Somebody had to coordinate this whole thing. The pilot was too busy because the demands that were made on him in terms of accuracy of flying the headings and maintaining altitude were pretty stringent. Otherwise, you're going to get an error. So they turned to the navigator, and he had this equipment to use, just some main controls, then the readout from the Schran set itself, and then a plotting table at the bottom. And the navigator could plot himself down on the bottom of the line crossing and make sure they were following that figure 8 and not getting too close to the perpendicular bisector where the errors would start cropping up. But Mr. Wing Commander Ross never lost out entirely about his straight line computer to fly gaps to ensure you didn't get gaps in the photography. Here it is. It was devised. It was never used by the RCAF. Actually, there was a lot of training that went on during this period, primarily for the Schran operators. It was a very difficult task. They're using these two controls, one going each way, and the hand coordination was there. And if we had a good operator, the end result from measuring the Schran was 1 1/3 inches in a mile. 1 1/3 inches in a mile. That's how good some of those guys got at keeping those pulses aligned. But there were 2 of the Schran operators aboard, and they often switched between 4 transits. It was, they had to concentrate pretty hard. I mentioned the pilot training, and it certainly was an error. It was a difficult task. Not only that, the navigators, for the most part, insisted that all turns had to be in flat turns once you were flat on once you started the figure 8 crossing. No more tilt in the wings. That wasn't fun. You couldn't do it. As I said, the trials proved sufficient there. They were done in an area at Rockcliffe where we had a very precise baseline measured by first order triangulation, and we put 3 stations in there, and the accuracy that came out with measuring those lines was well within the 25 meters that was demanded of the maps. So we had a system, and it was go for a trial on Mr. Ross's approval, starting in Winnipeg, and to check this line between Ottawa and, between Winnipeg and Edmonton, not Ottawa and Winnipeg, not Ottawa and Edmonton. The project began in 1949 out of Winnipeg, and one of the good features of that was that the North American datum for survey is at a place just south of Winnipeg, at a place called Reed's Farm in the US. And so right away, the Schran program was tied to the North American datum, which was a big advantage. I want to next look at that business of flying the transits, which we did. But one of the things that was necessary was that we had to measure the wet and dry bulb temperatures every 1,000 feet from ground level to the operating altitude of the aircraft, which was usually 20,000. And the climb, level off at every 1,000 feet, and the second navigator was using a psychrometer, operated right about there where the cockpit is. And you wet a sock on a bulb and pushed it out into the airstream and waited until you got the low temperature from both of the thermometers that you're reading. Then climbed another 1,000 feet and did the same thing until you got up to your operating altitude. It was very costly in time, very costly in fuel. They tried to avoid it in the design of the system in the first place by using a radio sound system that the aircraft would drop. Didn't work, didn't happen. And I cannot find any reason in any of the literature why it was put aside. It's just not there. The ground station itself was based on a transponder, a radar transponder system, and each station was put in by a Cancel or Norseman. They're all put in on the water, or nearly all of them, because in that northern land there were no other places to sit down and find these points. It was all waterborne operation, Cancel, Norseman, and eventually Otter. And this is a photo of a Cancel unloading at one of the stations, and you can see there's a little boat there, and they had to load everything, unload everything from that little boat, haul it into the shore, and then walk it up the highest hill in the whole area. And that transponder weighed a good bit. The whole station weighed 4,000 pounds, including the tents, the food, the APUs, the gas barrels, everything that had to go. If it was a Norseman or an Otter that put the station in, it took an even longer time because, of course, there were fewer people to help. Because notwithstanding what the medical people would have said at the time about aircrew doing work like this, they did it. They had to help put in the station, and they did. And sometimes these stations would take 12 or 14 hours of work to get in. The Cancel was great. They had a kitchen on it, so they could have good food while they were doing their work. But the Norseman or the Otter, much longer, sometimes days. Now, in the lower latitudes, the people lived in tents, and here's a typical situation with the 60-foot Charan antenna, which was directional. It had to be lined up with the appropriate line that Lancasters were flying, as we'll see later. Here's another one, a little closer shot, and that's where some of them stayed, and some of the Charan stations were in, if you were in the center of a chain, they might be there for a month. It wasn't all boredom for them, though. They did have shotguns, they did have fishing rods. Now, later on, as we moved into the Arctic Islands, they went into Nissen huts. And there would be two of them. One was an equipment hut and the other one was the living quarters, and they were both heated with propane. So there were lots of propane bottles went into those stations. And here we see it, on average, to do an Arctic installation, took a minimum of 3 ski wheel decks to take in the station, because now it didn't weigh 4,000 pounds, it weighed 8,000. Now, these sites that I've just talked about where the ground stations were, somebody had to find them in the first place, and there was a team called the Geodetic Team. And the year before we were going to fly the lines between these stations, the Geodetic Team went in and selected a suitable site, suitable line distance where possible, and they would establish the elevation of it with barometers, and they would also put in a monument that would appear in the photos if they were good enough. Now, a little bit about the data reduction, and I assure you that it's only going to be a very little bit. Chelan teams, the teams that did the work for the geodetic survey and checked out the measurements that we were making with the Lancasters, those detachments accompanied us in the field. And there were usually 2 or 3 permanent people, and then maybe 4 or 5 students that they hired from universities doing maths and physics that were familiar with the kind of work they'd be doing, and they would be there. And so they stayed with us over the period of time. And then as we would return from a flight with the film taken of the set, and when we were doing line crossing, we took a photograph of the counters every 3 seconds. And so they then plotted all these distances, ended up with a big fat parabola, and the lowest point on that parabola was the distance between them, and they had 8 of those on each day that we flew a line. Now, sometimes the measurements didn't agree, and if there were more than 50 feet difference, we had to refly the line, at least once. Most of the time, the refly would do the trick, but there were times when we had to do more reflies than that, particularly in the Arctic Islands, because the signal attenuation of the radar over ice and snow is much greater than it is over the land. And so the signals, by the time they got to the aircraft, were much weaker, and therefore gave the operators much more difficulty aligning them. Okay, now I'm going to show you what happened. There's a whole chain for Canada. This slide shows the summary for the whole chain, and there's some interesting points in here that I want to draw your attention to particularly. And the first one that I want to point to is a third from the bottom on the right, the Dakota hours. Look, we had 20 sites installed that year, and we flew 1,264 DAC hours. If you look at another site where we're just using the cancels, you can see that there's 700, 800, 1953, and I'm going to talk about that in just a moment. There were a lot of hours used, but look at the number of lines we flew in 1953, 101. 1950, the squadron was on its own in the PA, and they had all of their own facilities, their own kitchens, everything. It perhaps was one of the happiest detachments that they had because of that reason. 1951 was Yellowknife, and believe it or not, we have a member in here that was part of that system in 1951. You were there in 51, Alec? Yeah. Then in 1952, we used both Yellowknife and Churchill. We moved halfway between the summer period because the chain stretched then across the top of Hudson Bay. Yellowknife was interesting. It was a gravel strip, and Noel mentioned before about filing the nicks out of the propellers, and that certainly was a factor with the old Lancaster. We had a problem. 1953, I mentioned it. It was a big year. We flew 101 lines. We were based at Frobisher Bay. Alex Saunders was the ops officer, and I was his deputy that year. And we flew the early lines over on the side there. We flew them and then landed in Bruce Bay, did an arrow in, and then flew lines going back the next day because it saved a lot of transit time. It also saved us from eating the food in the American mess in Frobisher Bay, which was something else again. But that year, we did have a lot of trouble. There was a lot of communications blackout early in the year, and at times we would transmit a schedule for the Chelan stations to follow, which lines they were to put their antenna on for a 2-hour period. And then we would go out with the Lancaster and hope like hell that they had got the message the night before. Sometimes they did, sometimes they didn't. A couple of times we tried to go down and fly over the station in the direction that we wanted them to point the antenna. Yes, they would recognize it, but by the time we got over and did it to the second station, the first one had turned off. And often we went home without anything in our pocket from those. 1954 was a year completely different. We were then talking about the Mid-Canada line, and they stopped the Cheran program to do a special project across the 55th parallel. I think I've got it. There. We did that grid across there, and we did it with Cheran recorded photos, so that not only were we taking photographs of the Cheran set, as we flew along a photo line, we were taking pictures of the ground as well. This put a hell of a load on the navigators, because they had to arrange to get the stations to change their antennas into different locations as the aircraft progressed along the photo line, while the other navigator was trying to keep the aircraft on the photo line, and the Cheran operators were trying to keep the pulses lined up so that when we fired a picture of the ground, we took a picture of the counters, and we had to be at a reasonable angle so that the fixed accuracy that was calculated by Geodetic Survey fixed that site precisely. Because they were going to take those photographs, and they did, and they had to put the contour lines on them so that when they placed the stations, the Mid-Canada line stations could see each other with their electronic signals. So it was a pretty precise operation. This is, Wing Commander Schauer was the commanding officer then, and he was a person who believed in minimal interference with the people who were doing the job. And so he elected to command the detachment that year. On the right is me in a configuration some 65 years ago. And I was both the Cheran operations officer and the squadron adjutant. The two people on the wing commander's left, the first one is the RF exchange officer. He was the photo detachment commander. He just happened to be there that day. And the other one is the photo detachment ops officer. So for the most of the time at Goose Bay, when we were doing the Cheran, there was just the two of us, the wing commander and me. In 1955, there was a great controversy arose. The RCAF wanted to stop doing the Cheran because it took so many resources. And it did. 408 was certainly the biggest squadron in the Air Force at the time. We had 8 Lancasters, 6 Cancels, and 6 Norsemen, or 6 Otters, and all the people that went with it. At one time, we had on the squadron 1 wing commander, 1 squadron leader, 3 flight lieutenants, and 109 flying officers and pilot officers. So it was a good size. Anyway, the RCAF lost the argument, and they continued with the Cheran project because there was no civilian aviation agency that could have taken it over and done anything about it within 2 or 3 years. They didn't have the people trained, and they didn't have the aircraft in order to do it. In 1956, this is where a big change occurred as well, because we moved into the Arctic Islands. And this is a geodetic team that went out to look for the sites, and they did it just before. And if you look at that short little guy in the front, he was speaking to you just a few minutes ago. He was a navigator on that particular trip. The geodetic man was a man on the right. It was a Mr. Angus Hamilton, and he was the only person that ever saw the whole Cheran program from start to finish. A civilian from Geodetic Survey. Here's Churchill, and that was the main base for 1956 when they moved into the Arctic Islands. But it was the main base, but a lot of the flying took place out of Cambridge Bay and Resolute Bay. Here's the Here's a lovely spot where our airmen had to maintain our Lancasters down there in front. That little Nissan hut on the left was their shack for their tools and so on. The aircraft were maintained in the open as long as that ice strip existed. But it did melt, and they had to move on to the gravel strip later. But now it wasn't a summer operation, Cheran, anymore. It was an early spring operation, April, May, and June. And again, I returned to the statement of the 3 ski wheel decks having to carry out an installation. The other thing that happened that same year was that we got some new electronics. There was some new Cheran equipment obtained, and it was more accurate than the old stuff, and it was called HIRAN rather than SHORAN. And we had to add another operator to the aircraft because it required somebody to monitor the signal gain as it was coming to the aircraft. I think I got a... There they are. There's the man on the right is the guy monitoring the signal gain, and the one on the left is operating the new HIRAN equipment. This equipment was after the main spar on the aircraft. Supposedly it was heated. The Cheran operators would disagree with that quite sincerely. It was cold back there. Here's an Arctic station of the Nissan hut, and you can see they built a wall around the Nissan huts to stop the blowing snow from filling in, because it certainly did. And that was typical of the stations when we got finished with it. Here's somebody cutting the snow blocks for it. That's the wing commander doing it. He often went on the installations himself, and he believed in leadership by example. This is Thule, and that's where we conducted operations in 1956. There were no Canadian stations in the Arctic capable of handling the Cheran detachment. It's just far too big. So Thule was stocked up the previous year with rations and so on when they could take them in by ship. And then a lot of the DACs flew out of here as well that were on resupply. And the Lanks flew out of here, but they flew out of Resolute Bay as well. And one of the things that was critical to all of these operations was the communications. And we had a special communications set up for every Cheran station and the headquarters. And they operated 24 hours a day. That's how we had to try and provide safety for these people. It did work. I mentioned in 1954 that we had put some stations in early by using the ski wheel DAC at Goose Bay. And we put the stations in before breakup. We knew it was a risk, but we had to do it if that 54 program was ever going to get done. Well, after we flew the lines, the wing commander left, and the detachment commander left, and they left me in charge. And during that period, we had one hell of a snowstorm, and it blew over all of the tents on the station. And these men were left outside. I had to go to the base commander, the station commander at Goose Bay, and get him to borrow a helicopter from the Americans on the other side of the field to go and rescue these guys. That was a very important lesson that we learned for other years, and hence the Nissan hut and no more tents. Operations in 1957 started in April when some Dakotas started work installing the stations from Resolute Bay. And it finished, the line flying commenced on the 8th of May with the Lancasters, and the whole thing was finished that year. But we only had 17 stations in. It was very dense, but they were difficult, The stations didn't always go in where the geodetic survey people put them. Sometimes they had to go in short of that because the crews simply couldn't get the station where they wanted. They picked the best site they could, and that's the one we used. So 57 completed the Choran of those last lines. And here's Wing Commander Schauer being welcomed back to Rockcliffe at the end of it by Air Vice Marshal Kerr, who was the chief of personnel. I mentioned before that 408 didn't get much attention through these programs because of our location and the priorities of the other things, but the aviation world didn't forget about 408. Here's Wing Commander Schauer getting the McKee Trophy for 1957. That's George Hees presenting it to him. And here he is being inducted into the Aviation Hall of Fame by Grant McConaughey. In his usual, very modest way, he just claimed that the words were not his. They belonged to all of those who had helped complete the task. It's a long story. There is no way we could put that into an hour.